Hello and welcome to this video about properties of matter. In this video, we're going to look at physical properties and changes of matter, chemical properties and changes of matter, some different separation techniques, and the idea of the conservation of matter. Let's start with physical properties. What's a physical property? It's a characteristic of a substance that you can observe without changing the identity of a substance. Here are some different physical properties of people. Susie might have a body temp of 98.6 degrees Fahrenheit. She might get a fever. She's still Susie. Paul might be 50 kilograms, but he grows, gets taller, and now he's 75 kilograms. He's still Paul. We haven't changed his identity. Some examples of physical properties. Physical properties generally have to do with appearance and behavior. They could be the volume of a substance, the substance's melting point, at what temperature does it melt, at what temperature does it boil, what color is it, how dense is it, what state is it in a solid, liquid, or gas state at this time, what is the odor. Another physical property not mentioned here, viscosity. The resistance of a liquid to flow, that's a physical property as well. We can use physical properties to separate mixtures. Here in this picture, size is the physical property that is being used to separate these dirt particles and different sizes of rocks through this grate. Magnetic properties are the physical properties that are being used to separate this metal out of this sand. Really strong magnets are used in scrap yards and landfills to remove iron for recycling or to reuse to conserve natural resources. We've talked about physical properties. What are physical changes? There would be a change in the size, shape, or state of matter in which the identity of the substance remains the same. So in the end, that substance is still intact. We have simply changed its shape or size. Here we've done the same thing. We've mixed them together. These are physical changes, but the identity of those substances has not changed. When we change the state of a substance, let's say water, for example. Here's solid water, liquid water, and gas water. The molecules are still intact. You can still see the two hydrogens and the one oxygen, the two hydrogens and the one oxygen, the two hydrogens and the one oxygen. Its state has changed, but the substance itself is still intact. Another physical method of separation is called distillation. And that is using this change in state of matter in order to physically separate items from one another. Let's say we have a pot of salt water. Let me put this into our flask here. How do we separate that? Obviously, you cannot pour that through a colander. You still get salt water. We can't use a magnet. Neither salt nor water is magnetic. How are we going to separate this? If we put this into our flask and heat that flask up until the water reaches its boiling point, the liquid water, it will evaporate, it will vaporize here. And let's say we have a tube right here, and we run cold water on the outside of the tube, but we allow the inside to remain open. What happens when we vaporize the water and that water hits this cold area? It will then condense in this tube back into liquid water. And as it condenses, then it will run down this tube and into our distilled water area over here. We have a little Erlenmeyer flask where we're receiving that distilled water. And voila, we end up with salt left in the bottom of our flask over here and pure distilled water that's been separated from the salt over here. Now that we've looked at some physical properties and physical changes, let's talk about chemical properties and chemical changes. What's a chemical property? It's a characteristic of a substance that we're observing, and it produces one or more new substances. So flammability would be one. Obviously, here are some different substances that are flammable. That's a chemical property. There's some medicines or some different chemicals that when they're exposed to light, the light actually alters them and changes them into new substances, so they are kept in dark bottles. Those are chemical properties. So what's a chemical change? Well, a chemical change is actually called a reaction because it is changing one substance into an entirely different substance. These are all examples of chemical changes. Wood burning. You're taking fuel logs and oxygen. They're being combusted and burned, and you're getting an entirely different substance in the end. Carbon, ash, and water being evaporated. Food digesting in your stomach. This watermelon is being broken down in the stomach chemically after you chew it. Chewing is a physical change, but in your stomach, the acid breaks it down chemically and changes it into an entirely different substance. Steel rusting is another example of a completely new substance that is chemically formed. Anything cooking, this egg cooking or cookies baking, an entirely new substance is being formed there, chemical changes. So, what are some signs that a chemical change has occurred? One sign, a rapid release of energy. Heat, light, sound. When those kinds of things are produced, generally you can say that a chemical change has occurred. Here's an example of some of that, getting all of that. Formation of a solid. When we have two liquids that we mix together and we see a cloudy, milky solid that is being formed, this is called a precipitate, abbreviated PPT. We know a new substance has been formed. That's a sign that a chemical change has occurred. Oftentimes, bubbles will be an indication that a chemical change has occurred. Obviously not in the case of the carbon dioxide, but here when we mix baking soda and vinegar together, we get a new gas that is formed, and that gas is released via lots of bubbles, and that new gas is a sign that a chemical change has occurred. How can we use chemical changes? How can we use chemical changes to separate different items? We have to use other chemical reactions. Those things are rarely done at home, but in laboratory settings and in industry, for example, metals are separated from their ores and purified by using chemical reactions, chemical changes. Let's apply our new knowledge to the idea of weathering. Is weathering chemical or is it physical? It's both. In which of these pictures are you seeing chemical weathering? And in which of the pictures are you seeing physical weathering? Take a moment and think about it. Let's take a look at this statue here. This statue has actually been affected by chemical weathering of acid rain. The acid rain has chemically altered this statue and the substance in that statue. And other examples of chemical weathering would be oxidation of different metals. You might have a statue made out of copper, which gets oxidized, and it changes it. You can see that it's a different substance. Silver tarnishing is another chemical weathering or chemical change. The tarnish is a different substance than the silver. Here's a picture of Dover Cliffs in the English Channel. And what do you suppose that kind of weathering has happened here? It's actually both chemical and physical. The chemical part is that these cliffs are made out of a rock called limestone that contains solid calcium carbonate. And when the water is just a little bit acidic, it contains a little bit of dissolved carbon dioxide, which reacts with the calcium carbonate and ends up forming calcium bicarbonate, which is this white stuff you see on the cliff. That's the chemical change. Obviously, there is physical weathering that occurs here as well, with simply the water and the wind acting on these cliffs to cause a physical change rather than a chemical change. Here is an example of physical weathering as well, from water that has gone through this canyon or this area that has created this physical change. Here we have an example of physical weathering called frost wedging, where water gets into cracks, and then when it freezes, it expands, it pushes those rocks apart. It is important to remember matter is always conserved. It is not created and it is not destroyed. Therefore, we can talk about the law of conservation of mass in any chemical reaction or chemical change. The total mass of the reactants, which is what we start with, all the substances before the chemical change, is going to always equal the total mass of all the products. Those are the substances at the end that you get out at the end after the chemical change has occurred. And you can look at this little experiment that someone did and just see, wow, if I have baking soda and vinegar in this little Erlenmeyer flask and I put a balloon on the top to make sure I'm capturing all of the gases that are going to be created here as well, because I'd like to know the mass of all the gas that's produced as well. I'm not going to ignore that. I'm going to take the total mass of all the products, and that gas is a product of this reaction. I can see that I have 3.861 grams of reactants. And as this reaction is in the middle of taking place, I still have 3.861 grams. But in the end, when the reaction is all done, the total mass of all my products now, I have different products. I've had a chemical change and I have new things that are formed, but my total mass is still 3.861 grams. You can read through some of these advanced ideas. If you have your own ideas, please come up with those. Fractional distillation, that's another really interesting one I didn't list here, but look into that. What is that and what is it used for? How does industry use it? And I look forward to seeing what you come up with, and we'll see you in class.